There is some debate about when and why the former sea dwellers ventured out of the water, but there is no doubt that they did by the late Devonian times. Skeletal and fossil evidence from this time period has helped scientists develop theories as to why this transformation occurred. The first classical theory as to why reptiles moved to land was proposed in the 1950s by Alfred Sherwood Roemer. This theory stated that fish moved onto land to escape from drying pools using their feet, to either bury themselves in the mud and sleep through the dry season, or to walk across land in search of another pool of water. This theory has been criticized because there is only limited evidence of droughts and because only minimal land adaptation would be needed as opposed to the complex amphibian limbs of the fossil evidence. A simpler theory states that lobed-fin fish moved on land in order to tap into new resources. These resources include plant and insect food that were not being exploited by anything else, and oxygen, which, due to the increase in oxygen levels in the air, was more plentiful on land than in water at that time. But the more important question is, what physical characteristics had to change for them to better survive in this new habitat? To better understand this, we are going to look at the bone and muscle structure of each fish or amphibian and compare them. Lungfish first developed in the early Devonian period, but they are still in existence today. Lungfish breathe through gills, but they also possess a modified swim bladder, which they use as a lung. When the waters of hotter areas dried up, only the lungfish were able to bury themselves in the mud and breathe, making them the only ones to survive, and consequently adapt into tetrapods, or early four-legged creatures that roamed the land. Lungfish eventually developed into ripidistans, like the Euthenopteron. Ripidistans are the in-between stage between fish and tetrapods. They are not yet the four-legged tetrapods that ventured onto the earth, but they have many similar physical characteristics which helped them later develop into tetrapods. The Euthenopteron was a Devonian fish that developed pectoral fins with a similar bone structure to that of a hind limb in order for it to drag itself through soft mud with its fins. Here you can see the humerus, the upper arm bone, the radius and ulna, the forearm bones, and you can even recognize some wrist and finger bones in the pectoral fins. In order for the Euthenopteron to develop into an early tetrapod, several things had to occur. Although scientists do not know the exact steps that needed to be taken to develop a tetrapod, they know that the fish had to start breathing oxygen, which wasn't hard since they already had lungs. They know that the backbone of the fish had to modify in order to prevent the back from sagging when the animal stood up, and that new muscles had to develop to hold the animal's head, support the back, and prevent the rupture of the belly due to the weight of the internal organs. Ichthyostega was an early tetrapod whose fossil was found in Greenland. As you can see, Ichthyostega has a fully developed shoulder, elbow, and wrist joints, well-developed back muscles and a spinal cord for support, and clearly formed hands and feet. Also, the Ichthyostega has strong hip and shoulder girdles to stabilize the limbs and provide attachments for new leg muscles, which helped it to walk. As you can see, these physical adaptations would have been easy to develop. Euthenopteron already possessed all of the bones needed to create Ichthyostega. They just needed to strengthen and grow. From this stage, tetrapods were free to live on land and morph into modern animals, such as amphibians, reptiles, birds, and mammals. It turns out we still have a lot in common with our fish and tetrapod ancestors. Our bone structure is actually quite similar to that of a fish, further proving the theory of tetrapod evolution. The nerves that control sensation and movement exit the spinal cord between the vertebrae in both sharks and humans. We also have a similar spinal cord to Ichthyostega, the early tetrapod. It is also because of our fishy anatomy that we have hernias, hiccups, and hip and knee problems. If fish hadn't come ashore 408 million years ago, we wouldn't be here today. Knowing about the anatomical changes that tetrapods went through back in the Devonian era is knowing how humans came to be.